Good morning, 9th standard. The next exercise that we are going to do is exercise 13.4. This is based on the surface area of a sphere and a hemisphere. And before we start the exercise, as usual, we will write down a note. And in the note, we are going to write down the formulae that are used here. So if we have a sphere whose radius is r, there is only one surface, the whole outer curved surface. In case of a sphere, the total surface area and the curved surface area are one and the same thing, and the formula for the same is 4 pi r square. Now for a hemisphere means half the sphere. This will be like an orange cut in half or a lemon cut in half. So hemisphere with the radius as r will be having a circular base and there will be a curved surface. So this is the base, which is circular, and the radius is r. So for this, the curved surface area is the half of this, so 2 pi r square. If for the whole sphere, curved surface area is given by 4 pi r square, then for half sphere, the curved surface area will be given by 2 pi r square. And the curved surface is actually the surface on the outside. If you are considering an orange or a lemon as a sphere, the outer peel represents the curved surface. And if you are looking at half an orange or half a lemon, then the curved surface will be the half peel which is left, the outer covering. Now in case of total surface area, we need to take the curved surface area plus the base area, which is a circle. So the curved surface area is 2 pi r square, the base area is pi r square, the total becomes 3 pi r square. Let us do a few questions from the exercise and see how we apply these formulae. Question number 1 from exercise 13.4. It's a simple application. Find the surface area of a sphere of the radius as given. So there are 3 parts. You have to find out the surface area of sphere in each case, since they have not indicated. Now by default, whenever the word surface area is used, it means total surface area. But this is the special case of a sphere. A whole sphere, its curved surface and its total surface, both areas are equal. Let's solve these parts one by one. Question number 1. First part, the radius is given as 10.5 centimeters. I have to find out the surface area of sphere. So this will either be TSA or CSA, and they are both same for a sphere. For a sphere it doesn't matter, and this is given by 4 pi r square. So 4 into 22 by 7 into the square of the radius, 10.5 squared. Let's solve. So I'm doing two things simultaneously, removing the decimal and simplifying the square. This gets simplified. Now I'm cancelling this. I'm left with, I can also cancel this. So I'm left with 22 multiplied by 3 multiplied by 21. Let's find out the answer. This comes out to be 1386 centimeter square. Now let us do the second part. In the second part, the radius is given as 5.6 centimeters. Finding the surface area of sphere, this will be given by 4 pi r square. As I said, it's a simple application. 5.6 squared. Now the simplification part, 4 into 22 by 7 into 56 by 10 into 56 by 10. So these get cancelled, and I'm not cancelling 10 this time because it will not be completely cancelled. I would have to divide later on. So I'm just going to multiply the numerators, and multiplication of numerators gives me 39,424 by 100. Now I will write it as a decimal. This will be 394.24 centimeter square. Question number 1, third part. I've been given the radius as 14 centimeter. Now again, total surface area of sphere is given by 4 pi r square. Use the value of r and simplify. 14 square, so 4 into 22 by 7 into 14 into 14. This comes out to be 88 multiplied with 28. Simplify your answer. It comes out to be 2464 centimeter square. Now the next question from this exercise: find the surface area of sphere of diameter as given. Now there is a slight change from first question. In first question we had to find the surface area of sphere, the radius was given. Second question, again we need to find the surface area of sphere, but instead of radius we've been given the diameter. So using the diameter, we first of all will find out the radius and then apply the formula for the surface area. Let's solve these parts one by one. Question number 2, first part. The diameter is given as 14 centimeter. This means the radius will be equal to diameter divided by 2. This is 7 centimeters. Now I can find out the surface area of sphere. Now for sphere, once again, the surface area means the total surface area or the curved surface area. They are both equal and given by 4 pi r square. Use the value of pi and r and simplify your answer. So this is 4 into 22 by 7 into 7 by 7. So this comes out to be 616 centimeter square. Question number 2, second part. The diameter is given as 21 centimeter. This implies the radius will be half of 21. I am not simplifying, I'll use it as a fraction. The surface area of sphere, 4 pi r square. Use the value of pi and r and simplify. So this is 4 into 22 by 7 into 21 by 2 into 21 by 2. Simplifying and cancelling, I am left with the answer comes out to be 1386 centimeter square. Question number 2, third part. The diameter is given as 3.5 meters. This means the radius will be equal to 3.5 divided by 2. Simplifying, removing the point, I will get 10 in the denominator. I'm cancelling these two, dividing them by 5. So the radius comes out to be 7 by 4 meters. I'll be using it in fractional form. Surface area of sphere is given by 4 pi r square. So 4 into 22 by 7 into 7 by 4 squared. Now the simplification. These get cancelled, these get cancelled. Let's cancel these. So I get 77 by 2. So this comes out to be 38.5 meter square. The next question that we have is question number 3. First and second question were based on direct application of the formula for surface area of a sphere. The third question is based on application of formula for total surface area of a hemisphere. It's a direct question. Find the total surface area of a hemisphere of radius 10 centimeters. R is given. We know the formula 3 pi r square. The value of pi is given as 3.14. So it is just simplification. Let's see how the formula will be applied. Question number 3. We have been given radius of hemisphere as 10 centimeters. Now we have to find out the total surface area of hemisphere. If it were a sphere, it doesn't matter whether we write it as TSA or CSA, because for a sphere both are same. In case of a hemisphere, it's important to indicate, and the total surface area of a hemisphere is given by 3 pi r square. Let's use the values of pi and the radius. Pi is given as 3.14. The radius is 10 squared. So 10 square is 100. Simplifying, this comes out to be 942 centimeter square. Question number 4. The radius of a spherical balloon increases from 7 centimeters to 14 centimeters as air is being pumped into it. Now imagine a balloon which is being inflated. As the air is pumped into it, its size increases. The balloon is mentioned to be a sphere in shape. So its size increases with increase in its radius. In first case, the radius was 7 centimeters. Afterwards, its radius became 14 centimeters. Find the ratio of surface areas of balloon in two cases. So we find the surface area using radius 7, then we find the surface area using radius 14, and then we find out the ratio of our two answers obtained. Let's write the answer. Question number 4. So I'll be doing it side by side, case 1 and case 2. In first case, the radius was 7 centimeters, and in second case it increased and became 14 centimeters. We have to find out the surface area of spherical balloon, and in both cases it will be given by 4 pi r square. So this will be 4 into 22 by 7 into 7 square. And again in the second case, the surface area of spherical balloon will be given by 4 pi r square, 4 into 22 by 7 into 14 square. Now we have to find out the ratio. Let's find the ratio. Ratio of the two surface areas. So we have 4 into 22 by 7 into 7 square over 4. This is from case 1 and this one is from case 2. So 4 into 22 by 7 whole square, 4 into 22 by 7 into 14 square. These get cancelled, so I'm left with 7 into 7 in the numerator, 14 into 14 in the denominator. Simplifying, I'm left with 1 by 4. So the ratio is 1:4. The next question that we have is question number 5. A hemispherical bowl made of brass has inner diameter 10.5 centimeters. Find the cost of tin plating it on the inside at the rate given. The rate is 16 rupees per 100 centimeter square. Now, keeping two things in mind, we have to tin plate the inside. Since the inner surface is to be tin plated, we need to find out the inner curved surface area. Secondly, we have been given inner diameter which can be used to find out the inner radius and hence the inner curved surface area of hemispherical bowl. Once we have the curved surface area, then we can find out the cost. Let's write the answer. Question number 5. We have been given the inner diameter of hemispherical bowl, and this is given to be 10.5 centimeters. Since we have been given the inner diameter, let's find out the inner radius. So the inner radius will be diameter divided by 2. Simplifying, removing the point, working this out, dividing by 5. So this comes out to be 21 by 4 centimeters. Now we have to find out the area to be tin plated. Area to be tin plated is the inner curved surface area. So the curved surface area of a hemispherical bowl, this is given by 2 pi r square. So let's use the values of pi and r. This is 21 by 4. Now simplifying, 2 into 22 by 7 into 21 by 4 into 21 by 4. These get cancelled. So I have got 63 into 11 by 4 centimeter square. Again, I'm not simplifying. I'll be using this as such for the next step. Now the next step is to find out the cost. So let's find out the cost. Cost of tin plating. This is given as 16 rupees for 100 centimeter square. So for 100 centimeter square, the cost is 16 rupees. Let's find for 1 centimeter square. This will be 16 over 100. Then we find for the area that we have calculated to be tin plated. So 16 over 100, this is the cost for 1 multiplied by the area for which you need to find out the cost. Simplifying. So I am multiplying the numerators and I will obtain the answer. Use the denominator to introduce the point. 2772 by 100. So it's 27.72 rupees. This is the answer for question number 5. The next question that we have is question number 6. Find the radius of a sphere whose surface area is 154 centimeter square. Simple question. You have been given the surface area. You have to find out the radius. So make an equation using what is given. Surface area equal to 154, and from there evaluate the radius. Question number 6. I have been given the surface area of a sphere as 154 centimeter square. Now for a sphere, the total surface area and curved surface area are both same, and the formula is 4 pi r square. The value is 154. Use the value of pi and simplify the equation to obtain the radius. So r square comes out to be 154 into 7 by 22. 4 is also in the denominator. So this comes out to be r square equals to 49 by 4. So this means r is equal to square root of 49 by 4, which is 7 by 2 centimeters, the units of radius. So this is the answer for 6th question. Later on in the chapter, you will come across a similar question where the surface area of sphere is given. Instead of radius, you have been asked to find out the volume. So what you will do, first you use the surface area, find R, and then use R in the formula for the volume and obtain your answer.